Hi, everybody. Nice to see you in here. Welcome to my presentation. I'm very happy to be here, finally presenting an in-person conferences, and I'm also very happy that you all are here because Pat this morning was just explaining to you guys that you're supposed to talk to people at conferences as well and not just see all talks. And so if you're here, I just assume that you genuinely want to see my talk, which is great, especially because Bruce is currently presenting in the other room and his talk must be really, really nice. So happy that you all are here. And yes, welcome to my presentation. Funnily enough, at my workplace, we need to do these courses on very soft skills, like ethics in the workplace kind of stuff. And there was one last week, which was, funnily enough, how to give a presentation. Unfortunately, I did not attend this course, so if anything goes wrong, maybe that's why. But my coworker actually did. And then I was asking him, so what did you learn about this course? How do you actually give presentations? And he was like, nobody's going to remember what you said. So, usually the audience is actually getting approximately 20% of whatever you're saying. But one really nice way to make people remember you is to make yourself relatable with the audience. And he was suggesting like pretending to stumble on my feet or something like that, so that, oh, people remember this girl that stumbled on her feet. But first of all, I am not too sure about the healthcare policy that I have here in the US, so I decided not to do this kind of stuff. But if you really want to relate to me, I need to give you this information about the fact that I'm tired as hell, extremely jet-lagged. I am hungry. This is lunchtime almost, so I can imagine all of you are hungry as well. So please relate to me. Listen to me, because I will do my best to make this entertaining at least, so that you remember something or you remember me. Now, enough complaining, let's get started. Who I am, Ilaria, it's written here. I go with Ila. This is probably the first time in my life that I actually put a who I am slides in my presentation. Not because I represent a company and I really want like this company to be represented, which I don't, but mainly because I'm really proud of what I'm doing right now because I finally finished my master's. And I moved to Amsterdam starting my PhD program. I also have a topic, so if you ask me, like, what's your PhD topic 1 week ago, I would start profusely sweating and panicking because I didn't have any, but now I do. So I feel nice about this and what I'm doing. And of course, being a researcher means that I am very impartial in all of this. I do not represent a company. You're going to see me with Postgres t-shirts and not AWS or any other kind of t-shirt. But on the other hand, I am beginning to develop opinions, which is not always great because it means that I'm going to pick fights. So yes, I am in this uncomfortable situation in which after years of being in the Postgres community, now I am beginning to be aware that other things exist. And I'm starting to see the bigger picture in this. And we are talking about benchmarking in this presentation, so I might have maybe a little bit of hot takes on how Postgres actually performs. So anyway, I am digressing. I have 50 minutes to give this presentation. I expect me to digress a lot because I don't expect this talk to take 50 minutes. And yes, so following from this, as I said, I've been using Postgres since 2018, which probably given the average age of this room is not a lot, but it is 1/5 of my life, and when you're 24, that's a lot of time. And why am I bragging about this? Because part of the reason why I'm still here, and I started from very clueless bachelor student, and now I am presenting in New York wearing this very cool stuff t-shirt, is because this very same project is one of the reasons why I'm still sticking around, and because I was pulled into the community by this project, which was presented for the first time a few years ago in this Google Summer of Code program, which deserves a slide. So here we go, a bit of shameless advertisement about this program because it is really important for Postgres. So what happens here? We have Google that is presenting this sort of scholarship for people to contribute in open source, which means that we take students, usually from the bachelor's or master's, and we have them develop for 3 months over the summer in open source code. And Google is giving them money, basically, so that students are young, they don't get paid, we need to pay rent, and Google is paying our rent. But we are doing some useful work for some open source community, which is great, and it's also a very nice way to encourage young people to participate to the community, because the average age of just developers is, sorry in advance for this, a bit high lately. So yeah, so we want young people to actually take part in this. And this is what this project of the Performance Farm is doing. So we have participated in Google Summer of Code for now 16 years, but specifically this Performance Farm has been around since, I think, 2018. Yeah, according to my slide, this 2018. So yeah, we started this, actually Postgres developers started this by, according to GitHub, I see commits by Thomas, Dave, and Mark, who are probably around here. And then it was presented as Google Summer of Code project, and it was taken over by this guy, who I do not know. And then the following year was taken over by myself. So unfortunately, this is my code, so probably not perfect, but it's working. And then after 2 years, I was not allowed to do Google Summer of Code anymore, because you can do this for 2 years. But the project was far from done, so I decided to join the dark side and actually become a mentor for this project. And then I became an organization admin, and now I am very deep into this, and there's no way out. So I guess this is how I got started. So this is nice. Why? Because for once, we have a project here that is obviously fully open source. It's not backed by any company. I mean, unless you consider Google as a company, but I don't think it works like that. Google just pays. Google doesn't care about what we're doing. So this is a project that is made almost entirely by students, which is great. And hopefully it's going to be useful, because finally this thing, after 5-6 years of Google Summer of Code, is ready. So I am here to pitch that, not to do some shameless advertisement about how cool it is that we have young people finally developing something, but also because this thing is ready. So get to know this, please use this, and help us with this, because even if it's ready, we could really use some help. So this is the background of this. This is the history of this project. Now let's actually get started. So what the hell is this? Sure. Yes. Oh, yeah. Because we finished GSoC last week. It's finished. So it is a summer program that starts in June and ends in September. And literally last week we finished. Yeah, thank you for reminding me that. So we successfully completed Google Summer of Code. We had some students passing, most of them passing, I think 9, was it 9? Something like that.
We're not all done yet, but yeah.
Yeah, but we are going great. So we are just wrapping up a successful closing of the Google Summer of Code for 2022. So I was saying, Performance Farm, yes, kind of self-descriptive. It uses Postgres, and it is about performance. But in practice, this tool is a benchmarking suite that is aimed to test the performance of our beloved PostgreSQL. Why do we want this? Because benchmarking is important. Because I assume that a lot of people here are DBAs or DevOps or software engineers, and you don't really care about this. You just want our data to be there and hopefully replicated, the database not to crash or anything, which is understandable. But we also need to keep up with speed, performance. We want to develop a product that is fast, other than usable and reliable, right? But benchmarking is a little bit of tricky topic, because if I talk to any database developer, all of them are going to say that they are developing the fastest database in the world. And I mean, yeah, Postgres is the fastest database in the world, and then I go to ClickHouse people, and they're like, oh, my database is the fastest in the world, and then I go to Amazon people, and they're like, oh, my database is the fastest in the world. I'm like, So I'm young, but a little bit capable of some critical thinking, and something doesn't sit right with me with this. But anyway, I'm a researcher. I deal with this 8 hours a day because we are also trying to develop, obviously, the fastest database in the world, right? And I'm so tired of this, and I don't want to deal with this, so when I go home, I need to do this. So we decided that even though we are benchmarking our database, we are not going to pick any more fights with anybody, because everything is going on, we're good. We want to do a very impartial suite that is indeed performing benchmarks, but rather than trying to compare databases with one another and make this race about who has the bigger car, we are trying to analyze performance changes in the PostgreSQL itself. So, in other words, this is a tool that is aimed for Postgres developers to make sure that they are able to compare performance changes within commits and versions and everything that comes with that. So, as long as your thing is Postgres and as long as your thing builds in the same way as Postgres builds, you can use your thing. It also supports custom Postgres installations so that you don't have to wait until your commit gets merged if you want to test this. You can just pull up your own Git repository and run benchmarks on that one. And why is this? Because we lack a centralized benchmarking pipeline, so please don't kill me with this. But this is how it gets done. It is probably incomplete because I'm not a developer, but from what I understand, yes, we have the patches that they get submitted to the mailing list, and then some people with their eyes actually look at this code and like test this code, try to break this code. We have the commit first website and so on, and we have the build farm as well, which is basically the very same thing as this, but for builds. So you just build your code in different machines and make sure that it's working. But we have not really something about performance, right? And I don't think we're going to have it anytime soon. There was this very informal discussion on this Postgres Telegram channel about switching the development from mailing lists to GitHub. And don't get me wrong, people were really, really polite while discussing this, but the general gist of it that I understood from my 24-year-old perspective is over my dead body. So I don't think it's going to realistically happen anytime soon. So we are going to keep this very decentralized infrastructure, but still we don't have a proper full CI/CD pipeline just yet, and we might use some additional tools for benchmarking and testing. So this is why we have this thing. And yeah, that's it. This is composed by a client and a server, of course, like most infrastructure. So the client is basically a glorified bash script, which is in Python, and it just does the magic on your machines. So you just put it there and let it do the job. And then the results are going to upload it to this server side, which is very simple application with an API and database and so on and so forth that allows you to collect your results and expose them in a website. So the client specifically is doing these steps, so it clones the repository from scratch, because we're not going to use your existing Postgres installation. Your data is going to be safe. We're not touching any of this, at least not intended. And then it's going to build Postgres from scratch, install Postgres again from scratch, and then it's going to run 2 different benchmarking workloads, which are respectively pgbench and tsph. Now, what is this? I decided to also put some slides on this because I was at the conference last week and I was mentioning this to someone, and turns out that they didn't know about this, because I'm not taking anything from granted. I am sorry if you already know this, but for correctness, I'm going to explain this. pgbench is our official benchmarking tool, and of course, it runs on Postgres. It is transaction-oriented, which makes a lot of sense because Postgres is mainly transaction-oriented. And if we want this, we're going to want to measure the TPS, so higher is better. So it just does the job. It just run some select, some updates, insertion, some vacuum at some point. And this is how it looks like, very simple. Sorry, I was too lazy to change my theme of my terminal to fit with these slides. So you're going to have with the black background. I mean, it's very, very simple. It just does the thing, and we, at some point, will want to have this, which is the latency, and this, which are the TPS. So we want this thing, but executed in multiple different machines over multiple Postgres version and multiple Postgres commits, so that we can actually compare the results between one execution of pgbench and the other to see if everything is going properly and nobody is messing up while developing the database. And on the other hand, we have TCPH, which is, again, controversial because it's a kind of workload that people optimize their database specifically to work with. So yeah, if you talk to a researcher, they're going to be like, oh, my database is perfect on TCPH because we tune the optimizer in order to understand this kind of query and do the magic. So yes, if you talk to a researcher, it's a bit controversial, and it's also an OLAP workload. And I mean, the silver lining is that Postgres is very open about this, and if you open the wiki page, it's going to be written there that Postgres is disappointing when dealing with TCPH, which is true, don't get me wrong. But why do we want this? Because even though Postgres is not the best at this, it is still important to have a different kind of workload and a benchmark that every other database is somewhat able to replicate. And also because there are some parts of Postgres that might actually go wrong or right if touched. For instance, we want, I don't know, to see how beautiful we parallelize joins or how good our optimizer is. Spoiler, not much. So we also decided to include this TPCH benchmark in this suite. And how does that work? Well, it works by generating some pseudo-random data about these orders and in this fake company. So this is the schema. You can see there's a lot of foreign keys. And it's a bit messy, but it's also fairly simple. It's just some suppliers, some customers, and orders, and so on and so forth. I mean, this is also good to measure other kind of stuff, like how fast our database is when loading the data in bulk, how fast we can create indexes, and so forth. So ultimately, it's kind of nice to have it here. And on top of that, we also collect more stuff. So we have information about the mounts, the hardware specifics, the OS version, compilers, obviously the Postgres configuration, because that is tunable as well, sysctl, collect-d, and so on and so forth. So, because obviously we want to give developers also this kind of information, since it is very hard to infer what is going on in a database without having complementary information about the system. So this is mainly why we put all this bunch of data there, which obviously means that our website results in a mess with a lot of information and a lot of stuff to think about when examining these results. But in the end, we collect a lot of data, and it is very easy to understand if something odd in the system is going on. And this is the server side. We have Postgres running, obviously. And on top of that, we have Django and JavaScript. Why? Well, because it is very easy to maintain for the Postgres infrastructure team. It used to be in React, then it was switched to Vue. Then, if I recall correctly, it was vanilla JavaScript for a while, and now we injected also Django templates just to copy everything from PGWeb and to have the same maintainers maintaining PGWeb, also maintaining this thing. So this is how it works. I hope I convinced you that this stuff is actually important, and I hope this sounds cool. So how can you help? Because we do need help. First of all, if you're not a developer, help us testing. So take one of your servers laying around, put the client script, set up a cron job, and give us some data. Because ideally, we want a lot of machines, a lot of users, so that when people are trying to analyze the performance of their commits, they have the biggest amount of information that we can find. Run the benchmarks, help us reporting bugs, because yes, as I said, this is developed by students. I am a student myself, or at least I was until a couple of months back, and I do not trust my code. It's probably very ugly. So please help us finding issues, reporting bugs. I'm not saying that you should fix the bugs, but probably we don't even know that the bugs are there. So, and yes, tell us what features you would like to see, because this thing is up and running-ish, but it's definitely not finished. So we plan to also present this in the next Google Summer of Code editions. So it would be nice if you could help us saying what kind of features you would like there to be. So yeah, of course it will be buggy, but you have been warned, so now you know what's going on. If you're a developer, on the other hand, just use this tool, because this tool is for you. This tool is for developers to be able to understand if a very specific commit somehow downgraded our performance. So just look at this website. It's very easy to understand. And it's also very easy to know what commit and who wrote this commit. So you know who to blame. And, but I don't think this is going to happen. I assume that everything is going to be great, so keep up with your job. Basically, just, I don't know, use this at some point. If you are in the Postgres infrastructure team, please put this damn thing up. Okay, this is a bit of an inside joke. You need some background story. This guy here is supposed to put this thing up on the server since March. And this didn't happen yet. I mean, you're also in the infra team, so. Yeah, so now after a lot of work and a lot of iteration, this is finally compliant to the whatever requirements that you want to run. So why do we need this up? I mean, of course it's up right now, but it's up on one of the servers that are set on specifically for GSoC. So yes, it is working, but we need it on the Postgres server because we need our authentication method to be there, because I'm not going to handle any kind of data. This is going through the same registration system as Postgres. So you can log in with the same account and you're going to be in without any additional steps whatsoever. But in order to do this, yes, you just need it to be in the same place and access to the user database and so on. So we're not there yet, not because it's not ready, but because people sometimes have a lot of things to do. So after 8 months, still didn't find time. Okay, so anyway, all right, so assuming that this thing at some point is going to be up and running, I think this is enough of information that you have to do. Now, you know how it works, you know what it does, you know why we need this, so let's take a look at the thing, I would say. So, obligatory disclaimer, we are not CSS people, so it's not going to look good, but it's going to look better than the Bill farm, for sure. So, so this is what you can see there. This is the machine list, fairly easy. You know, like we approve machines so that people don't accidentally DDoS our servers trying to approve machines. And yeah, you have this information. Fun fact, this thing here is our server from our research center. And the very same weekend that I added this thing, our IT infrastructure team decided that we want to save the environment, so we're going to shut down the power in all the research center. And they had this generator, which was borrowed by the physics research center around the corner. So we borrowed the generator, we put it there. We found out that there was a problem with the cooler in the generator. So it's been a week, and machines are still down. So we have no results for this boy, but not because this infrastructure is running, just because people doing things in the Netherlands. So Anyway, also fun fact number 2, it is still not up because currently we are subject of a cybersecurity attacks on our mailing list. I don't know what the hell they want to steal, probably our benchmarks, I don't know. So anyway, the results that I'm going to show are mainly produced by this boy here, which is my personal laptop, which sucks really hard, so I have to do micro benchmarks because I don't want to fry my CPU. So take everything that I say in this presentation with a grain of salt, because this is just testing, this is not production, and also my ThinkPad is sometimes weird. But anyway, after this, I'm going to give you just a few examples on this. This is what you can see of one TCP/IP execution. We have 2 things here. One is the throughput, and one is the power score. So this is going to be slightly complicated to explain because I'm not sure I understand this myself. But I asked my advisor, and he said that basically throughput is the different queries executed at the same time, and we still want TPS, so higher is better. While power score is basically representing the capability of our system to fully use the resources that are allocated to it. So instead of running the same instead of running multiple queries concurrently, we are going to run one query at a time, so sequential access, in order to understand how good our system is at using resources and parallelizing the very same query. So, I mean, just to state an example here, take this thing, query 2. It has a very high power score, which is good because also higher is better with power score, but it's a very, very low throughput score. So what is going on here? Well, this is going on here? Query 2 of TCP/IP is this ugly monster here. So I'm not sure if you can see this from the back, but I couldn't make the text larger because this query is enormous. So it's basically a very big join with a nested subquery here. So what is going on? Of course, this is parallelizable because Postgres can parallelize this kind of workload. But our optimizer is unfortunately not able to unnest this query. So we're going to have here a very, very bad performance. So this is an example of how to interpret the results of this, because more often than not are going to be false positives or false negatives, and also it is important to take into account what kind of workload we are doing. So yes, query 2 is not going to be great, but maybe at some point somebody is going to push a patch to fix this issue. But this is another talk for another conference, so stay tuned. But yeah, after all, we're not doing that bad, because if we look at the composite score, this is always between 2,000 and 3,000. So yes, this is 15 minutes ago screenshot. So yeah, I finished my slides at least. But yeah, this is the kind of trend that you can expect from this. So it should be ideally either an horizontal line or line pointing upwards. But as I said, there is also the possibility that I was playing video games or something while doing this. So don't trust my CPU that much. Just see that this is the results that you can expect from this benchmarking suite. And yeah, this is PGBench, so other workload. And this is an example in which something is actually going on, because you can see here that we have latency. So latency lower is better, and TPS higher is better. But here we have the opposite way around, right? So we have a drop here. So for instance, I'm not saying that this is real world. I'm not saying that this is right. And I'm also not saying that I am able to understand what is going on here, but I'm doing my best. So yeah, if you're using this and you suddenly see this trend dropping and the other trend going up, this is the kind of situation that you might want to look into. So as I said, it's very, very easy to know what commit is the culprit of this, because it's literally written here. And there's also going to be a link on the Git page. So this is, for instance, the kind of commits that are the culprits of the performance drop that I show you here. So I'm not a developer, I don't know what is going on, and I also noticed that most commits are like fixing the arguments at the function, fixing typo in the comments, fixing grammar, code refactoring. So I would rule these out. It is also funny that there is a commit in this trend that is called fix use pages on Windows, but my laptop is Linux. So I generally don't know what is going on. I still think it's the first one. So handling some sick term in some wall, something, something. But as I said, I don't know. Don't shoot the messenger, please. But one other thing that you can do in this case is enable some kind of email notification so that if your results are actually fishy or drop over a certain amount, you get the email notification so that you can wake up in the morning and you're really happy and then you see your emails and then you get this automated notification that you screwed up. So I imagine this is a nice way to start your day. But if you care a lot about Postgres, you can also do this. So yeah, we have another example of this is Postgres 13, which apparently a lot of people are still running in their production databases. So yeah, it's also important that also the older versions get committed. So this is nice. This is actually, I think, going, yes, this is going where it's supposed to be because latency is going down and DPS is going up. So whoever is doing this, good job. And yeah, we have a bit more stuff. This is an example for a run. So this is a number of benchmarks that are being done. Of course, obviously, it's more often than not multiple execution because we want this on warm cache, ideally. And then from the run, you can go and access all the other information. We have the statement latencies as well with the statements. And on top of that, we also have PGStat statements, which is hands down our favorite extension of Postgres. So we are also going to have this kind of workload with the query, the line of the query, because of course you also want to know what query is triggering my drop down in performance with the query ID. Fun fact about this, I just found out that we have negative number of query ID. I was this close to actually started screaming at my student because I was like, why are negative numbers in here? Then I read the patch notes and turns out that from Postgres 11, this is on purpose because the size of the integer was extended, and this is yet another example of Postgres developers messing up with the size of their integers. So at least this one got fixed, which is good. So now we have negative numbers, and that is perfectly normal. But yeah, you're going to find a lot of information here, max execution time, the mean, the standard deviation, and so on and so forth. So yeah. This is indeed a lot of information. We collect, obviously, the Postgres settings. Now, in this screenshot, we only have the boring ones. That should probably not change in your default installation, but we still also have some to customize, mainly the log size and the log granularity, and most importantly, the share buffer size, and memory size, and so on and so forth. So that if anything changes here, is also tracked, and if anything happens here, everything is going to be tracked as well. So yeah, I think I've given you enough screenshots to look at and enough motivations to use this thing. So I guess we can just slowly wrap it up. So yeah, in short, I just show you this benchmarking suite that is used for Postgres developers to make sure that Postgres is still performing, nobody is messing up commits, and to see the trend of the performance in order to spot any kind of drop, to visualize this, to have an idea on what Postgres is going on over multiple branches, multiple commits, multiple machines, anything you want, you can put there, and it's going to be benchmarked, and you can look at it. So yeah. We also collect statement latencies, the logs, collecting, and so on. So this is why this project is so precious. I mean, yes, obviously because it's made by students, blah, 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 Google Summer of Code, yes, but also because it's important to test our database on performance, on how it works, on how fast it is. So please use this, because it's far from ready and it's also far from stale, because of course there's going to be more work to be done on this. I obviously plan to do this on Google Summer of Code. I mean, it is very certain that this is going to be a project. It is not certain that somebody is going to pick this up. And this is unfortunately out of my power, but for sure I'm going to continue mentoring this thing. And yeah, part of the nice things that we can have is adding the explain plans, which is going to be not trivial, but it might happen because obviously you also want to know what your optimizer is doing when you're running some queries, because it might differ from query to query and from version to version. Then add custom queries, which is also going to be a bit tricky, but let's see how that turns out. NYCSB, which is the Yahoo benchmark, and it is actually for OLTP systems. So the more benchmarks we have, the better this is going to be. And yes, we need your help, so please do. Use it. It's there. Use it. Put this up. That's also important. Find bugs. We really need to spot the bugs because the more you look at something, the less sense it makes. I'm not sure if any of you also feels like this, but when you are actually very deep into the development of something, everything starts to go all over the place. Request features, because we need students to take this project and work on it, and they also need to give them something to do. So if you have something in mind, please tell us. And mentor contributors, if you feel like it would be great to have somebody working on this, and if you're interested by this, and if you're interested by anything else and want to still participate in Google Summer of Code, please come. We need your help. So this is it. I am early. So yeah, this is to thank, of course, all the audience, but also mentors who have been involved in this project. Not sure about you because it's still not up, so half thanks. And anybody else who is involved in this, because through this project, I managed to get involved really in the Postgres community. So this thing has a special place in my heart, and hopefully now also a special place in the heart of the developers, because it's really cool. Thank you for the attention.
What PGBench scales are you testing, and is it related to are you testing ones related to the machine specifications, like how much memory it has specifically, and then are you altering shared buffers to be what's the relationship between those three things and what you're testing?
We're testing everything. The PGBench configuration is user-defined, and also the shared buffers and the memory, everything is user-defined. So in the benchmark that I was testing, I think it's micro benchmarks, not to have my poor machine burning or anything. So I'm not sure how actually this is useful, because usually we want larger scale benchmarks. But you can usually define all of this, because we have this very nice settings file that has approximately 50 settings that you can choose from. So we also collect different PGBench settings. So for each set of settings of PGBench, we're going to have multiple machines reporting, multiple iterations of this. So it is customizable.
Is there a place you think in the future where you'll be able to go and see what results other people have gotten? Is that something you're planning?
Yeah, all the website is already collecting all the results of everybody.
Oh,
so
I see.
all of this is public. I mean, I would show you, but it's not up yet. So, but yeah, I mean, maybe I can actually show you this thing. Yeah, I can. Did I accidentally? Okay, this is gonna be awkward because I don't see anything here. So I'm trying to open a browser page. I managed to open a browser page. It's on the wrong screen. There it is. So I got yes, I got this. Now I just need to scroll. Maybe I have this can help. Are you going to help me? They're not going to help me. Oh, maybe, maybe. So, so yeah, this is going this is what you can see here. We have the benchmarks. Oh boy. No, I'm sorry. I'm trying to click this button, but it's harder than I am imagining. Almost there, almost there, almost there. No, far. Can you click this button for me? Is it impossible?
It's backwards.
Yes. Oh, beautiful. Yes. And then you can see all the available benchmark configuration that we have here. So it's going to show basically these benchmarks for different machines. So we have currently 2 Ubuntu machines that are running this very specific scale. For this one, there is only 1. But I mean, this is still testing environment. So of course, you don't have a lot of data. But ideally, we are going to want all of this. So yeah, we have multiple configurations that can be used by the user. And then from this, you can see basically everything that you might need. I mean, not right now, but should be working at some point. Oh, Jesus. There we go. Almost, almost. Yeah, so this is it. We have owner, we have details about the machine. You can download the results in JSON because everybody loves JSON here. We have the command line, and we have the trends for all the branches. So this is what happened in Postgres 12. This is what's happening. This is the commits. This is information about the commits. And from this, you can, with the show button, you can also access the single statements of PG bench with the latencies and so on, and run 13 stable. OK, you get the gist of it. So this is how it works. And I hope I answered your question. Sorry, it took me half an hour.
Yeah, so I think just to kind of clarify, I think the general idea of what we're trying to do is to look at the performance of Postgres on a specific machine under a specific configuration with multiple different commits over time, rather than trying to compare against 2 different machines. But all of the information is going to be, up and available on the website is the idea.
Good. Can we have lunch?
Oh,
We
one more
can
question?
No, we cannot have lunch. Lunch is going to be delayed.
Any plans on the roadmap for support? I assume this is benchmark and database running on the same instance. Any plans for doing, benchmark client on one machine, server on another?
Can we do this? Can a student do this? Can a bachelor student do this?
Yes.
If so, sure, we
Sure
can
you
do it.
can.
Beautiful. Then I will add it to the to-do list of next year. So,
I mean, if Steven can get it posted. Oh, wait, sorry, hold on.
There isn't anything today that do that, but it's, I don't think there's any reason why you couldn't.
yeah.
It should be pretty straightforward, actually, to have this benchmark script run on a different system than the Postgres system. I think the challenge is
in-memory benchmarks, it's not that hard to
I think the issue there,
overloading the system with your running code.
I think the issue there might be, I have to look and see where we're pulling the configuration information, because we run things like collect D and grab that
Right.
information
Right.
as part of running it, so we'd have to.
Yeah, you'd probably still want the framework running on the database machine and then
Yeah,
give it the ability
yeah.
to say, please run the client.
So if you'd like to help, I have an idea of what you could do.
Any other questions?
Speaker away from my.
Awesome. Well, thank you so much.
Thank you.